Welcome to part 5 of the guitar pick tray series. Today we are going to go over the second adaptive clearing operation as well as get into performing our pocketing operation to finish the inside of our pick tray. So we did the first adaptive clearing operation with our 3/8 end mill previously. So we actually want to keep that same geometry and most of the parameters. So all that we need to do is right click our previous 3D adaptive clearing and go down to create derived operation. We'll go to 3D milling and then we'll click adaptive clearing again. That will bring over most of the parameters for us, and I'll show that to you. So now all we need to do is select the correct tool. This time we are going to be using a 1/4 inch end mill, and I am going to be using a 3-flute 1/4 inch end mill from Shars. So if you guys have never looked at Shars, go to shars.com and really look over their end mill offerings. They offer American made carbide at a very reasonable price. In fact, you can find American made tools that are around the price of a cheap Chinese end mill from Amazon. So if you get a chance, go ahead and go check them out. So again, we're going to select our tool, click OK. Now we are running at 8,000 RPM and 30 inches per minute. So because the diameter is smaller, we can introduce more deflection, so we're going to be running slightly slower. Again, we can skip over the geometry tab since it's a 3D toolpath and Fusion takes our geometry into consideration for us. If we go back to the heights tab, you'll notice that Fusion, since we did the derived operation, kept our parameters for us. So the top of the model is selected so that we are not, again, cutting air. All right, moving on to passes. You'll see that we still have our 20,000 stock to leave and a 30,000 optimal load. Now, unfortunately, our end mill diameter did increase, so we're going to adhere to that around 10% rule of thumb for the diameter of the end mill, still sticking at 8%. So I am going to go at 20 thousandths for the optimal load. Again, sticking around that rule of thumb. 10% of the diameter, we are using a smaller tool. All right, now we will just go ahead and go to our linking tab. And again, you'll notice that we have our ramp clearance at 10 thou for any helical entries. And we have our stay down level to least, which is exactly what we want as we went over in the previous tutorial. So we'll just go ahead and hit OK. And then we will quickly simulate this toolpath. And what you should see is that we will go in and clean up those tight areas that we were not able to get during the first operation. So we will go ahead and click simulate. And you'll notice this toolpath again just takes a long time because it is a roughing strategy. We're removing a lot of material. So we'll slow it down so we can see. We'll press OK. So again, we're just going in and getting rid of all that material that we couldn't get with the 3/8 end mill. All right. So we'll speed it up a little bit and wait for the simulation to finish. There we go. So now our part is completely roughed, and we'll go ahead and start finishing our part. So to begin our finishing operations, we're going to perform a pocketing operation. So we're going to clean up the floor and the side walls on the inside of our pick tray. And so the first thing I'm going to do is I'm going to hide our parametric stock just to make it easier to select our geometry. So I'm going to navigate through the assembly. There we go. Close that, and then we're going to go to 2D and we're going to go to pocket. As always, we are going to select our tool. I'm going to go to my 770 library and select the same 3 flute 1/4 inch end mill from Shar Tools. Select OK. And we'll go over the speeds and feeds. We are at 8,000 RPM again, 30 inches per minute. I'm comfortable with 30 inches per minute. I think I will be able to get a nice surface finish without any tool deflection. And you'll notice our feed per tooth is closer to 1 thou, 1.25 thou. The rule of thumb there is you typically want to be at 1 thou feed per tooth or more. That will prevent any type of burnishing. You don't want to burnish, that will ruin your end mill. So I'm okay with that. We'll go to geometry. Because it's a 2D toolpath, we need to select our geometry this time. So we're going to select the inside contour here. And you'll notice our floor has turned blue, so we will be performing our pocketing operation on the inside floor of our pick tray, which is exactly what we want. So we'll come down, we will finish the floor, and then engage and finish the sidewalls in one toolpath. All right, so let's go to our heights tab. And again, you'll notice that Fusion has chosen the top height to be the stock top. We want that to be the model top again so that we prevent ourselves from cutting air. Our first operation was a facing operation where we removed the 50 thousandths from the top of our model, so we no longer have stock above the top surface of our model. So if we were to choose stock top, we would just be cutting air. All right, so we're going to choose model top for the top height, model top for the retract height, and for the clearance height. We will want to go ahead and examine the bottom height. We notice that that is a selected contour, so that is the floor that we selected. So that is perfect. We'll now go into the passes tab where we have some more interesting parameters. So the main thing we want to do here is select our step over. We want that to be between 50 to 75% of our end mill's diameter. I'm going to go with 50%, which is 125 thousandths or 1/8 of an inch. And what that does, again, if we go too large on our step over, we run the risk of introducing cusps, which are little lines between our step overs that you can see and feel, so it will degrade our surface finish. We don't want that. The next interesting item that you could choose is morphed spiraling, and that will really just smooth out the toolpath, and it will try to get rid of any sharp turns. This can help reduce any kind of whisper marks you may leave behind. And I'm not going to do that, but I will show you here in a minute what that does. And I'm not going to use more spiraling because I feel it doesn't give you a visually appealing surface finish. So I'll show you that here in a minute. And we are going to uncheck stock to leave because this is our finishing operation. We don't want to leave any stock. We do want to finish our sidewalls in the same operation or the same pocket operation that we are finishing our floor. So I'm going to go ahead and select finishing. I'm going to select 3 finishing passes, and I'm going to make my finishing step over at 10 thou, which again, that will prevent any tool deflection when we engage the sidewalls. Now, you do not have to finish the sidewalls with the pocketing operation. Others may prefer to just finish the floor and then come in with a 2D contour to finish the sidewalls. I feel that I get a perfectly acceptable finish when I go ahead and finish the sidewalls with the pocketing operation, and it saves me machine time. So that is what I am going to do. There are 2 other parameters I would like to check. One would be smoothing. So this is going to smooth out the line segments in our G code. And the final one is the feed optimization. So what feed optimization is doing is it is going to take into consideration the kinematics of the toolpath, and any time that there is a sharp turn, your machine has momentum, and when you make those sharp turns, the machine actually has to slow down and stop before performing that turn, which can lead to little whisper marks in your surface finish. So by selecting feed optimization, Fusion will try to, again, make those transitions easier and smoother on the machine. So I normally only select that when it is a finishing operation. All right, we will now get into the linking tab, and the main parameter here that we want to consider is the ramp. Because we have already hogged out all of the material inside of our part, it would be a waste of time to perform a helical entry. So what we're going to do is we're just going to plunge down and then just instantly start finishing our floor. So now I am going to go ahead and click OK, and then right click and simulate. Actually, before we do that, we'll go over the morph spiral. So if you look here at our toolpath, you'll see it's triangular and it's visually appealing, but we do have some sharp transitions or some sharp turns here that could introduce little whisper marks. Again, feed optimization will help relieve some of that issue. But if we right click and we go back into edit, we go to passes and we enable use morph spiral machining. Click OK. You'll notice that Fusion indeed smooths the toolpath, so we don't have all those sharp turns, but in my opinion, this will not leave a visually appealing surface finish, and I want to be able to show the pick tray off to, your friends or your family, as a first part you made on the CNC machine. You want it to look nice so you can show off. To me, this doesn't. Even though there's nothing wrong with doing this, it's actually probably better in terms of, again, providing a smoother surface finish and reducing the whisper marks. So I'm going to go in back to edit, and I'm going to disable morph spiral. And again, just because it provides to me, in my opinion, a more visually appealing surface finish. All right, so now we're going to right click and simulate. We'll slow it down so we can try to capture the plunge at the beginning. So here we go. So we're plunging straight down, and then we start performing that triangular motion, which just gives us a nice surface finish. Okay. And now we'll just speed it up until we engage the side walls. We'll slow it down so you can see that we indeed finish the floor and then finish the side walls in the same operation. So that is it for our pocket.